welcome guys, welcome to my YouTube video. So this video I want to prove that the famous result 1 from infinity 1 over n squared equals pi squared divided by 6. And if you go online, and usually people use Fourier analysis, also complex analysis, also the famous Taylor series that developed by Euler. So I think you guys already know this kind of way, so I don't want to waste your time and spend the same time doing other people's already did the YouTube video. So I want to introduce the somehow a different method developed by Kabi. Okay, so before I start, hope you guys subscribe to my channel. Okay, so this method is developed by a mathematician Kabi, which is a very astonishing result. Okay, so since we don't have anything, right? So our goal, so our tool will be calculus. So the problem is that we forget about Fourier analysis, complex analysis. That's not the residue theorem, that kind of things. We only have the elementary calculus. Okay, so now let's consider. So the tool is to how to write. So the key is that you need to write this into integral, and then you just try your best to solve this integral, and hopefully you are smart enough, then you get the answer. Okay, but let's see. Let's maybe compute another series which is much simpler. Is that this guy? Okay, so let's call this is I. Okay, so let's reminder fact is that so our goal originally is this one. So I can write as this. Okay, I can write as this, right? So I can pull out 1 over 2 squared, and it become the same thing, right? So this is the same technique. Same idea is that I only pull out all the odd exponent. Sorry, the even power. So this tell me that this is 1 plus 1 over 4, right? And let's see, right? So and let's see, this is S, right? So this is let's see. Sorry, so this guy become this. The rest these are I plus 1 over 4 S, right? So we get S. Okay, so this tell you that I equals to this. So our original answer, this S will be 4 divided by 3I. So if we can find if we neglect all the even power and we get only R square, then suppose we find I, then we can easily find S. Okay. Yeah. So let me just delete this because I think it's easy to remember. So the point is that we only need S equals to 4 divided by 3I. Okay, so the next thing is that write I into integral. Okay, so let's see. So it's not easy to see, but let's consider this integration like 0 1 0 1 1 minus. Okay, so let's see. Okay, so let's see. So we only did 1 divided by 2n plus 1 square, right? So the key idea is that the x 2n plus 1, let's say x 2n dx 0 1, right? This integration will be 1 over 2n plus 1, right? So in order to get square, right, all you need to know is that you get another y, so you get y2n dy, right? So this is very trivial. Yeah, but so that means you can write I as a summation from n to infinity 0 1 0 1 xy to the power 2n dx dy, and write as 0 1 0 1 summation n from 0 to infinity xy 2n dx dy. Okay, so in order to do this, you need to use some kind of uniform convergence, but that's a little bit sloppy, so let's forget about it. So your I become 0 1 0 1 1 minus xy x squared y squared dx dy. Okay, so the final thing is that solve this integration. So the final step, let me use a red. Okay, so now become crucial. Final step. Solve I using your calculus. Right. So yeah, using your calculus to solve y. I mean, yeah, do your best. Okay. But the copy is a smart guy, right? You find out that let's say x is cosine u, sine v. Let's see, it should be sine v cosine u, and y should be sine v cosine u. Let's say we use these two variables, and then let's first compute what is the result. Okay, so the first I want to okay, so let's see, 1 minus x squared y squared will be 1 minus sine u squared sine v squared cosine v squared cosine u squared. Okay, and your dx dy need to change as a Jacobian, right? So it becomes du dv partial xy partial uv, and take a determinant. So this guy will be partial x partial u partial x partial v partial y partial u partial y partial v du dv. Okay, so yeah, this computation is very easy. Let's maybe do this here. So partial x partial u will get cosine u cosine v, and the partial x partial v will give you minus sine u cosine v squared. So cosine derivative is negative sine v. And this partial y partial u will give you minus cosine square u sine v sine u. And this partial y partial v will give you cosine v cosine u. So you calculate determinants, right? It's just product of this minus this. So you get a cosine u cosine. So you see these two are reciprocals, right? So their product is 1 minus sine u squared sine v squared cosine u squared cosine v squared. Okay, so if you're smart enough, right, you see they are exactly the same. So amazingly, if you do this change of variable, your I will become du dv, right? Because your dx dv is this, and then you will just delete this. Okay, so finally we are very easy, right? We only need to get the uv region. So uv, and then remember our xy are 0 0, right? So we need to map this to this let's maybe change a little bit. So we need to map this into this. Okay, so let's see. So if x is so y is so if x need to be okay, so if x can be 0, then sine must be 0, right? So if x can be 1, then they must be the same, right? So which tell you that in order to x to be 1, right? Your u should be your u should always should from 0 to pi over 2, right? In order to have x is positive, and also your v should be, and your x and your v are the same as u, right? So you know that the region should be 0 to pi over 2, 0 to pi over 2, in order to for all the cosine and the sine to be positive, right? So this, okay, and so you see this 0 1. But you have a point like 1 1, right? 1 1. So 1 1 means what? Well, 1 1 means that your sine u should the same as cosine v, right? If you 1 1, and also sine v equals to cosine u. Okay, so which tell you that I'll tell you what. So this is 1 minus sine u squared. Tell you what. So yeah, this is right. So which tell you that u and the v should be pi over 2 minus u should be pi over 2 minus v, right? So sine u will be cosine pi divided by 2 minus v. So you see, so v should be pi divided by 2 minus u. So if you allow u to be pi divided by 2 minus v, then this will satisfy. So that means your region should be this one. Okay, I mean, yeah, this is the results. If you see carefully, I mean, you can do it carefully by mapping each line, try to get the answer, right? But the key I already said. Since you have 1 1, right? So you have these two relationship. So you can get a boundary must be pi divided by 2 minus v. So u plus v equals to pi divided by 2. Okay. Okay, so the answer is easy. The answer is just half, right? This red area, so it's half times pi divided by 2 squared. So it's pi squared divided by 8. Okay, so that means what we prove is that 1 divided by this, 1 divided by 1 squared, 1 divided by 3 squared, 1 divided by 5 squared, 1 divided by 7 squared must be pi squared divided by 8. Okay, and then we already show. So remember that we already show our original 1 over square 1 from infinity is just let's call it s, right? We prove that s must be 4 divided by 3 times I. Right, so your s will be 4 divided by 3 times pi squared divided by 8, pi squared divided by 6. Okay, so this is a proof that amazingly, without further analysis and without complex analysis, without a Taylor series, and it's 100% rigorous. Once you prove it's convergent. Okay, so and I will leave another video that I have another video that I will post below. That you can also show that 1 over n to the 4 from n from infinite 1 to infinity will prove that it's pi 4 divided by 90. And you also need to use you can also prove it without a complex analysis, Taylor series, or other. You can use a calculus, and then even though you don't know the calculus, you can still start from here to get here. Okay, so from here, then you can get zeta to n for n equals to greater or equal to 1, and the integer without any Fourier analysis, complex analysis, Taylor expansion. If you just generalize it, if you just generalize what I told today. Okay, so yeah, see you guys next video. Hope you guys subscribe to my channel. Thanks.